Good morning, good afternoon, and good evening to all the people joining in from around the world. This is the 8th webinar presented by IET Karachi Network. We are a global platform. I, Nawal Naveed, would like to welcome you all to our webinar. Hope you all are doing fine. During this session, your microphones will be muted and your video will be closed for now. And we are going to communicate with each other and make this webinar very interactive through other methods, one of which is the polls. In a few minutes from now, I'll be raising a poll so that I can inquire from where you people are joining from. I hope all of you are doing good. Let's just wait a little while for people to join in. We have participants from all around the world. So I'm going to raise a poll in which I'm going to ask which part of the world you're joining from, and you're going to vote for it. I hope all of you can see the poll. Okay, I'm now receiving the votes. All right. Brilliant. I want all of you to participate so that we have a fair idea. Everyone raising their hands, I want you all to participate in the poll and then we can just answer your questions. Yes, I can see a lot of participants. I think all of you can see the poll. If not, you can write it in the chat section. If there's any issue, I'll just solve it. Okay, like most of the people are voting, so I can guess a lot of you can see the poll. All right, I'll end the poll now and we'll just share the results to everybody. So like 76% of the people are from Asia. We have 14% from Europe, 7% from Oceania, and 3% from South America. Thank you everybody for joining in. I know a lot of people are still coming in, so we have a lot of things for you. Let's just move forward. I have some important instructions for you. Let's start with the question and answers. Throughout the course of this webinar, you're going to have questions in your mind. And whenever you come across any question, you're going to put it in the Q&A tab. This tab is dedicated for question and answers only, and we will be answering this in a separate section after the session is over in the Q&A. So please feel free to put your questions whenever it comes in your mind, and we'll be going to answer it live. The session will be interactive. As I told you before, we'll be asking questions through the poll, just like the one I asked you right now. I would like you all to participate. It was a great participation. I could see it. For the chat section, it is for comments. Whenever you have a comment, if there's a problem in the audio or the video, you can just put it there and I'll be able to solve it and answer you. Everybody who's raising hands, I can see a lot of raised hands. So please put your comments in the chat box because we cannot open your microphones right now, but I can read the chat box and I'll try to respond to you. Also, we are very welcome to feedback. I would like everybody to give their feedback through the chat section. Also, you can tell us about any of the improvements you want us to make or any other topics you have for the webinar. Let's just move forward with today's speaker. We have Mr. Tausif Ahmed Khan with us. He has done his MEM from NED University, BE Electrical from NED University. He has his PMP design thinking professional from IBM, sustainable energy from Arizona State University, USA. As far as experience is concerned, he has 6 years experience in advanced power distribution in Saudi Electric Company, along with 4 years experience in K Electric Pakistan and 2 years utility plant experience in Pakistan. He has completed various distribution improvement projects in Pakistan, successfully completed advanced distribution management system project SmartGrid in Riyadh, and his expertise is in ADAS, load studies, smart grid, and distribution automation and distribution planning, operation, and control. I would like to welcome Mr. Tausif Ahmed Khan, and he'll be having the control from now on. Good luck to everybody. I hope everybody learns a lot today. Over to you, sir.
Okay, let me share my screen first. Thank you very much, Ms. Nawal Naveed. And also, I would like to thank you, the IET team from UK and this platform, that they are providing very informative and technical sessions to the all professional all over the world. And I know these type of sessions and informative conversation are very useful, especially for the young engineers that are new in the markets and they want to start their career. So I would like to thank all participants that are come here from across the globe and giving us their valuable time to learn something and give their suggestions and everything. As already Ms. Nawal Nave gave introduction about me, I just would like to add some more things regarding the distribution projects. I have completed several distribution projects, improvement projects in Pakistan regarding the distribution networks, improvement of distribution networks, their analysis and load flow studies. Also, distribution management system, implementation of distribution management system in Pakistan. Then I moved to here in Saudi Electricity Company, and I am here in distribution department. And here we have successfully completed one state-of-the-art distribution project, that is advanced distribution management system, and we are using it successfully. And also Saudi Electricity Company now have introduced more projects regarding the distribution automation and smart distribution. And our focus and our vision, according to Saudi Vision 2030, to improve the concept of smart cities and smart urbanization. And as a utility company, our focus will be on smart grids and especially smart distribution is my department concerned. Before starting smart distribution presentation and discussion with you, I would like to know about your background. So I will request Ms. Nawal Naved, please raise for me 2 polls. Number 1 is, are you from background of power distribution? So can you, Ms. Nawal, right, can you raise this poll?
I'm doing that now. Let us all answer that. Are you from a power distribution background? I hope everybody can see the poll now, and I want you to vote for it. Okay, a lot of votes are coming in. Very good. I hope everybody can see the poll and they're voting for it. I've got a lot of votes already. Okay. Let's just wait for a second and then I will end the poll and you'll share the results. So I'm ending this poll and let's see the results.
Okay, that's great.
Yes, sir. We have the results now.
That's great. It's mean we have a largest community from distribution background. And I would like to also know about the work experience they have. They are experienced or young professional. So can you ask me for second poll for me that about work experience,
Yes.
please?
So now let's ask if the people have what kind of work experience, what time, and I'm launching the poll. I hope everybody can see the poll now. I want you all to vote for this one also. Okay, so the votes are now coming in.
That's great.
Thank you for being very interactive, everybody. I can see you all are voting as soon as I'm putting up the poll. That's very nice of you. So we've got a lot of votes now. I think I will end polling
Yeah,
soon,
close.
and I'm
Okay.
going to share the results. There you go,
Okay.
sir.
That's great. It's mean we have young engineers and young professional here. So it's very great. It will be very learning and interactive sessions. Interactive session, inshallah. Okay. Before starting off a smart distribution, we should know about the business case. Why we should start our smart distribution. So uh, I think now the situation of the world is changing very dynamically, and the advancement in technology is everywhere, and in near future very soon we have to be go for smart distribution. So business case for this one, distribution planning, as you know, is facing significant challenges in planning and development of electricity network due to various factors. The most influential factors are change of economic environment and regulation models, climate and weather patterns, implementation of new technologies, multiple customer choices, and transition of distribution network from passive to active and more sustainable models. In the last few years, we have seen dramatic change in the network natures and technological advancement, such as now near future, there will, or very soon, we will be having electric cars, distribution generations all over the houses. We will having some rooftops, solar panels, and some small wind turbines or wind energy or smart homes, artificial intelligence, augmented reality, and many things. So distribution planning need integration with conventional planning and advanced distribution management system for curtailing this modern issue. So I think our distribution planning should be aligned with our strategic goals of our utility company from portfolio level and from vision level, then portfolio, and then we should have several programs for our smart distribution and different projects to make our smart distribution fruitful from start to the end. And from top management to the down management, our smart distribution project should be taken the part. So this is the business case why we should go for smart distribution. Okay, before this smart distribution is basically under umbrella of a smart grid. So what is a smart grid? Smart grid is a concept with many elements. We are monitoring and control of each element in the chain of generation, transmission, distribution, and end use, allow the electricity delivery and use to be more efficient. As you know, nowadays we have a vertical system of our power flow. that start from generation. Then we have little or may you can say some automations level differently, but it is all vertical. Start from generation, then transmission, then distribution, and going to customer end, and it's all about vertical power flow and one way of power flow. But as you know, now the market's conditions and advancement in technology is changing, and we have there are some lacking between communication between all of these. For example, if we have distributed generations in our areas, we are using smart homes, smart meters, and different markets, electrical markets. So we need communication between all of them. So smart grid is basically what do smart grid make a loop between all of these, between market, generation, transmission, distribution, power consumers and service providers, and our control and operation, and make a loop. So there is better communication among all these electrical uh, power components, and power can be two directional. It can be flow inward or outward also as per our demand and response. So the term smart grid define a self-healing network equipped with the dynamic optimization technique that use real-time measurement to minimize network losses, maintain voltage level, increase reliability, and improve asset management. The operational data collected from the smart grid and its subsystem will allow operators sitting in control rooms or in planning departments to take the best strategic options. Here you see a term self-healing. Self-healing term like this. Sometimes we become sick. We have to go for doctor, for medicines. We have some medical list. We go for tests. So it is a long procedure for sickness. And sometimes if your immune system is very good and your immune system is highly improved, you are eating healthy food. So some disease self-heal. Same like for our distribution network. The normal distribution, we have to do every time many manual actions to control the outer management and many things, but smart grid will provide you self-healing network concept. So smart grid, this is the simple representation of a smart grid design. We have from generation, you can see here, there are some connectivity, bi-directional connectivity of communication with system coordination and situation assessment. And we have some transmission automation, then distribution automation, renewable integration, and we have system operation, energy efficiency or energy efficient buildings or devices, and distributed generation, and our smart appliances like electric car and electric storage. And these all are communicating to each other, and we know how we can optimize our power flow in different directions. Here is a comparison between today's grid and smart grid, and there are some preferred characteristics. For example, number one is active consumer participation. In today's grid, as you know, consumers are uninformed and they are not participating. But if you will follow a smart grid, they will be involve consumer demand responses. They will be actively participating in demand responses activities, and we can use distributed energy resource. Another one is accommodating of all generation storage option. As you know, this is a little bit obstacle in today's grid systems, but in a smart grid, it is very easy and fruitful. New products, services, and market and technology. You can say the advancement in technology. In today's grid, these options are limited, or you have to make different projects to take this new products, new advancement in today's grid. but smart grid will provide you this integration. Another one is power quality for the digital economy, because now our economy is converting from uh, conventional power to the electronic power. So you have many issues in near future for power quality due to the electric cars and electric storage and different optimal devices will be used in smart homes. So smart grid, because there will be too much calculations automatically done, so our power quality can be improved. Optimization of assets and operates efficiently. So this also in today's grid is difficult, but in a smart grid, you can prevent uh, losses and many things. Another one is self-healing. Whenever there is some outage in our normal grid system, we don't have a self-automation or feeder automation to isolate the faults or normalize the situation or prevent our assets. But in smart grid, there will be very good provision for them. We will see later. So as you can see here, there is a too much advantage of smart grid implementation nowadays. So by Mr. Novel, can you raise again here one poll? What you think all the audience about smart grid? In near future, the requirement of a smart grid for utilities companies will be optional or unavoidable or not required. So what our audience think about that?
Okay, so I'm launching the poll now and let's see what the audience thinks.
Okay, that's great.
I hope everybody can see the poll. I want you to start voting. So people have started voting now. I can see a lot of votes. I want everybody to participate. I've got a lot of votes. I hope everybody is seeing the poll. If not, you can put it in the comments or something so that I know. So I guess I have a lot of answers. I'm going to end the polling now and we are going to share the results.
Okay.
There you go, sir.
Okay, that's great. Means everybody know that it will be unavoidable around 83%, but 15% say it's optional. So I think it will be unavoidable in near future, or in some countries, maybe it will take some time, but it's sure it will be unavoidable. How you can curtail the new advancement that coming very rapidly in a new era? Like, for example, if, here in Saudi Arabia, I see the policies of Saudi Arabia is leading in the world. Like Neom city, they are developing smart cities like Neom. And sure, in coming future, there will be a concept of a smart city will be increased, and there will be too much work on this. So without a smart grid, it is not possible you can develop a smart city. It is not possible. So in some countries, it can take some time, but most of the countries, they want to advance in the current scenario of the dynamics on the world, they should go for smart grid. Okay, so now come to our topic, smart power distribution. Smart power distribution is the most important part for achieving the smart grid power system. It is like backbone, because you know this is the only system that is connected to your consumer, and consumer awareness is the most important thing in smart power distribution. So normal power distribution can be converted in smart power distribution by using a high level of distribution automation, smart grid methodologies, smart meters, some advanced sensors, and state-of-the-art or available communication technologies. So high level of available data and remote control capability will provide better operation and control for your smart distribution and your distribution network. So the question is, why smart distribution? So answer is, smart power distribution is a must-do thing in near future for all utilities company due to rapid technological advancement like distributed generation and artificial intelligence, augmented reality, smart devices, robotics, electric cars, and many electrical storage. Question is there. I think the people who are thinking that this optional, also they will be considering the cost, because you know, for implementation of a smart power distribution network, this is high costly. In start, capital cost is very high. So here I write that smart distribution is reliable, safer, smarter, self-healing, and cost-effective. So the term cost-effective here is some debatable. So I want to raise again another poll to be more interactive with our all audience, that how they think this is cost-effective or no.
Okay, I'll be doing that. So I'm launching the poll. If you think smart distribution is cost effective or not. I have launched the poll now, and I want you all to vote.
Yes.
The votes have started coming in.
Yeah. Because I know there are some doubts regarding the cost effectiveness.
So we're going to see what the people think about it.
Yeah.
So we have a lot of votes already.
Okay.
I would like all of you to put your questions in the Q&A session, Q&A tab, so that when we are going to have the Q&A session, we are going to answer your questions. Whatever, even if you have a question about the poll or you want something to be included, you can put it into the Q&A section. Sir is going to answer it in the end. So I guess I have a lot of votes by now, and I'll end the poll and share the results.
Okay. 80% of our young professionals and experienced professionals think that it is cost effective, and 23 or 20% they think it is not cost effective. So I want to clear the concept for both audience that it is cost effective or no. Here is a conceptual thing. You can see this on a screen. You have two type of telephone. Number one is very old. Before maybe I can say 20 years or previous, we are using this type of telephone and we are calling to each other and we are using effectively. And nowadays we are using this phone. So for the people who are think that it is not cost effective, my question is that this cost is $50 or maybe less than $50. And for this phone you are using right now, all people, it costs $500 minimum or maybe more. I make a very rough estimation. So if this is costly, why you are using? This is the concept of cost effectiveness, because this telephone, you only make calls, and this is a smartphone. You are doing a lot of stuff. You are watching the video, you are checking your sometimes thermal connectivities, you are also watching the news. You can read the newspaper and many applications. You can control your house, you can control your smart devices with the smartphone. So because now you are saving too much cost. in the whole picture as a portfolio level, because now you are not purchasing the newspaper, and sometimes you are watching the video, so sometimes you don't need TV like this, and sometimes many activities you are performing on your smart phone. So this overall it become a cost effective device. So you will, I am sure you will never use this telephone right now. If I will give you this one that it is very cheap, please don't purchase this smartphone, so you will say it is 100% not true. So this is the one aspect. Another one, technological advancement. You have to spend some money to be live in a technological advancement uh, environment. So this is the requirement. Sometimes some things become requirement. You cannot deny. So this is the concept of normal distribution and smart distribution. In near future, you have to be must to implement this smart distribution in your utilities network to give the reliable, optimal, efficient power supply to your consumer. It's all about your choice. Another why smart distribution? Because normal distribution, we have low system reliability. In smart distribution, we have high system reliability in terms of SAFI and SADI. Here we have manual operations. Here we have auto operations. In normal distribution, we have manual fault management, like we send crew to isolate some faults and then report. It's time taking. And smart distribution is self-healing. Here towards SADI, here you can improve up to 90% your SADI. We are using in our network in Saudi Electricity, and before when we are isolating our faults in outage management, it takes maybe 1 hour to 2 hours. But after using our ADMS software, we are isolating and normalizing our circuits maybe in 5 minutes minimum. So it's improved 90% your SADI. Here you have conventional load management. Here you have smart load management. You will think and your calculation will be considering all activities around you. Here you have one-way power flow and metering. Here you have two-way power flow and metering like net metering concept. Here you have conventional meters that somebody will have to go and take readings like this. And here you have smart meters that will be communicating to your smart homes, also communicating to the control rooms and your ADMS system. Here you have high risk. Here you have low risk. This in front of some disaster also, like now situation of COVID-19 and maybe some earthquake, some big disaster, some stormy condition, rainy condition. So your normal distribution takes too much time to have a normal supply, but in smart distribution, you can make many operations remotely and you can isolate many portions and your risk position decreases. In normal distribution, capital cost is also high and running cost is also high, but in smart distribution, you have cost effective, and when you will calculate the cost benefit ratio and or payback periods like this, some NPV and some financial calculation, you will find in near future, your smart distribution will be cost effective. The first part of your smart distribution is smart meters. It starts from smart meters. According to my ideology, because you can start like if you don't have smart meters in your network, you can start still by some implementation of ADMS softwares or some feeder automation. But if you will start from smart meters, you will achieve 100% your smart distribution target. So a smart meter is an electronic device with two-way communications that can automatically transmit customer energy consumption data as well as system operation information to the distribution operation centers. So in near future, when the home will become uh, more energy efficient and smart. So these smart meters will play a very vital role in communication with the smart devices to the home. The customer can download the application that are communicating with the smart meters and your smart homes. And in terms of demand response, consumer can, as per their choice, can switch off some devices or so that like this. So you can have a very good demand responses. Also, you know all the history and all things for your consumer behavior. So I would like to know how many of your utility companies, all the participants are using smart meter. So can you raise another poll for me?
Okay, I'm doing that. So you're
Is
going to
your
tell us
utility
if your
company?
utility company is using smart meters. I'm launching the poll now. I hope everybody can see the poll. So I want you all to vote. Okay, so we are receiving votes now. So we are receiving a lot of votes right now.
Okay.
Since there are people from all around the world, so we're going to have a mixed review here.
Yeah.
I guess I'm going to end the poll now and share the results.
Okay. 70% of the utilities companies of their participate using a smart meter. That's very good. And 30% are not using. So it's mean your utility company can implement this smart distribution very easily. And if they are using already, they can make more efficient and more advanced after research and development. We have in Saudi Arabia, we have a very big project for these smart meters already. So advantage of smart meters enable near real-time data collection and remote control capability, which provide great opportunity for utilities to improve distribution system management and operations. Some application for smart meters, automatic customer billing, that's very good. No need to take reading by personally or make use of your transportation. So this is become cost effective. You see, if things become cost effective when you apply smart things, that's reality. So automatic customer billing, also you can create the profiles, their user history, using how they are using billing history. So by using of application, your customer is very happy that you can see the payment methods, payment history, their uh, electrical usage, how they are using. So this is very good. Another one is state estimation of distribution system. You can uh, make estimation different area wise, different locality, different home wise, that there are some homes, they are smart. Smart homes mean they are adopting the smart devices and they are communicating with the smart meters like this. So how their state is, how power estimate is for them, for this area how much, so where to work for more smart distribution and where to make consumer awareness. So it's very important. Volt war management, you can see where is you have voltage problem by remotely, so where we have to increase, where we have loading unloading conditions, this transformer is getting low or getting high. So you can see remotely the temperature of your transformer like this. Remote connect and disconnect, this is another thing. For example, if your customer become defaulter or you have some problem, you can remotely disconnect your customer, and when they pay your bill, immediately you can connect them. So there is no time delay. between the disconnection and connection, demand response. This is very important thing. We will discuss also later. Load modeling and forecasting, smart home controlling, and load curves. This is another most important thing, load curve, because you know when you will be implementing ADMS, Advanced Distribution Management System. So for your all load flow studies and load management studies, all fault current activities, all type of analysis, you need load curve. And I know this is the most difficult part to implement load curves in your ADMS if you don't have a smart meter. You have to make long study, you have to make manual study to generate this load curve. Here in smart meters, these all will be automatically generated and you will connect this load curve directly to your ADMS system. So demand response. This is another important thing for smart meters. Demand response is basically a customer-driven actions to control load to meet a certain target. This approach is more customer-friendly. Here, customer will decide, I want to decrease the thermostat of this AC or no, and I want to switch off this light or no. This is different than demand-side management. Demand-side management, where load is controlled by utilities company to manage or shift peak like this. So this is not consumer friendly. They will decide that this time please decrease your all load. So this demand response by using smart meters, smart applications will be customer friendly and your customer will be happy. And also because this is actual response from consumer, so your load shifting, your peak load shifting and load management and difference between demand and supply will be very effectively managed. So this all about smart meters. These are from start. So sure, you need an advanced distribution management system for your smart distribution. This system is required. So there are many companies in the world that are providing services for smart distribution. So you can make research and development about their technology, and also before starting a smart distribution, you have to study your environment and your normal distribution, how your normal distribution is now, and how many technological advancements and study required, trainings, education required to move on a smart distribution. And the companies available in the market are providing solutions. So they are fitting to our environment or no, or we have to modify. So all these type of study is required before implementation of smart distribution. So here you can see the picture. The first one I take from my company, Saudi Electricity. And another one is from my previous company, K Electric, where I implement SIMDIST and distribution load flow. So you need this advanced distribution management system for connection, for making connection with the smart grid technologies from transmissions and your smart technological operation centers like this, and feeder automations for your load flow studies and to connect your smart meters. So all this integration required this advanced distribution management system. And this system can also be connected to your consumer software or like this. So this will provide you a backbone for your smart distribution. For this advanced distribution, I would like to describe more that how you will proceed. Number one, you have to build your network in these all type of software, and network can be built manually or by importing GIS. So I'm sure all of utilities company, if you are using the GIS and this is updated, so they can directly import the GIS from GIS, all the network in ADMS software, and they can start. And this GIS data should be updated. And before starting this purchasing this type of software from company, sure you will ask that how you are compatible with this GIS software or manual entries, how many feeders we can import like this, network flexibility. So you have to, first you have to make a network in these all ADMS type softwares. You have to import from GIS. Another thing, you have to check the quality of data for both, for real-time operations and for also planning purposes. You have to check the quality of data, your cable length, the resistance, and if you have transformer data, you have to put like this in this picture. We have to put, if you are familiar with the load flow softwares, if you are making some database, you have equipment database and you have a network database. There are different set of database. So, but I know all of you have knowledge about the database, but you have to put this data in quality wise, because if that quality of the data for your network builder is not good, so your result for load flow studies, I think, will deviate too much. So it's all about your threshold value, how your tolerance level for your accuracy. So the quality of data is very important. There, and another thing, then you will have to some real-time operation database like feeder automations. So you have to see the load profiles, practical operations approaches, and short-term load forecasting, load balancing, and many things. And you have to insert some queue management for outage management. You have to put settings for your FLISR, like fault localization and isolation, supply restoration. And this is for real time. Then another part will be, or you can purchase a separate software for load flow studies and link together. It's up to you. So load flow studies will be mainly for your state estimation, load flow, optimal power flow, and contingency analysis, fault calculation, optimal topology changes, your performance indices, many things, load growth. You can see, you can make many studies with this type of software, especially if you are for in K Electric, when I was in my previous company, we make some feeders then we make the network reconfiguration. So this network reconfiguration tool is very important. If your accuracy of data is very high and you implement network reconfiguration setup on your whole network, sure, it will immediately will give you very good NOPs and off and points. You can implement the result of network reconfiguration and show minimum 5% losses, the distribution losses immediately will decrease if you will do like this by network reconfiguration. And then you can make some studies for contingency analysis. If this feeder will trip, so what feeder is in our network is available to feed this in tripping position, and what will be the loading situation. So all these type of studies you can perform on your ADMS distribution software. Another main part for this smart distribution by using ADMS software is feeders automation. So feeders automation will start from your breaker in your primary stations. You can put some fault recorders that can record the short circuit current. You can put your fault recorder there, and these fault recorders and smart automation in primary station is a part of a smart grid. So this means your smart distribution is now connected with this smart grid system. Then you have auto RMU. These RMUs, ringman units, are not normal. These are auto RMUs that can control remotely and monitor remotely. Then you have smart meters available in houses and some breakers local. And then you have some off in your network and your another backfeeding options. So I will give you the example, the case study, the system we are using in Saudi Electricity, feeder automation and FLISR in ADMS. So in our system, or in ideal system, you can say if, for example, fault occurs here, so there will be short circuit current will flow in direction of primary, and fault recorder will record the short circuit value And the system of this FLISR, the method you already applied in your ADMS software, this method can be different, like 50-50 rule or by using fault recorder. It is as per your choice. So if you will put this option auto, so what will happen? This fault current will go in the fault recorder and the readings will go to your ADMS software and it will calculate by using fault localization method. This FLISR means fault localization, isolation, and supply restoration automatically. So your fault will be localized remotely, automatically by using different power calculations and by the rules you are set in your ADMS software. So then they will decide. In our case, we are using ADMS in Riyadh City. In our case, in 2 minutes or 3 minutes, we can decide where is our fault. After that fault localization, immediately these two RMUs will be switched off remotely automatically if you are setting on auto. It means your fault is isolated. The next step, this ADMS software will switch on this NOP and your supply will be restored and the system will check the loading here and the loading here and will give you a picture that how your fault localization, isolation and supply restoration is effective, and if there is some loading condition, so you can easily know. So this whole process, if you will perform manually, I am sure it will take minimum 1 hour, 2 hours, or maybe more in different climate situation, in different risk situation. It can be delay too much. So your SEDI will be worst. But if you are implementing this FLISR in your smart distribution, like we are using, we have many results. Maybe 5 minutes, we isolate it completely and supply restore. 5 minutes. So you can see the difference. Your supply isolation, so your supply normalization process is 5 minutes, and in normal distribution, it is 2 hours. So you can calculate how much revenue and profit you have lost. So it will be cost effective. Another thing, your performance indices like SEDI will improve 90% if you are using like this. So it will be on you how you will use. You will use like auto, or you will use partial, but I am sure it will give you advantage and it will give you 100% profit, and your performance indices will be highly improved. Okay, this all about this smart distribution means we have ADMS software, some planning software, some customer software. We have smart meters, we have feeder distribution automation connected all together. And in big picture, all these things are connected to a smart grid, and you have a smart concept. Because the time is running very fast. So, and this topic is like university nowadays. So it's take too much time. So now I will conclude on challenges for a smart distribution. So there are some challenges for implementation of smart distribution. I have write down here some challenges like distribution generation interconnections, customer awareness, demand responses, conversion of your available distribution system into smart distribution, your skilled workforce you required for this implementation, your education, your training and research and development, cyber security, creation of smart ecosystem, how you will build your ecosystem. So I will put my last poll here. I will request Ms. Nawal, please put the last poll regarding in your point of view, what is the biggest challenge? So can you please write for our audience?
All right, so I'm launching the last poll for today's session. I hope everybody can see it, and I want you all to answer now. Okay, we have started receiving the answers.
There are mixed, too much responses because this challenge is everybody perspective is different.
Yes. So people are giving a lot of thought in what they think is the challenge. Let's see what we have in the final results once I end the polling.
Okay.
I'll be giving you all a few seconds more so that you can read and vote for your choice. Okay, I guess now I will end the polling and share the result.
Okay. So we have very good and mixed response because this challenge is, all challenges have to be considered equally like this, but we have priority wise list. So now I will change also my priority, either 1, 2, 3, 4. Now here with the discussion with all of my audience, that number one problem is conversion of your available distribution system into smart distribution. Sure, 100%. Because you have to make a study that what you have in your current scenario, what you have your equipments, and how much your automation required, and how you can go for technological advancement. Also, there are some budget, some regulation from government, and many things you have to study for conversion of your normal distribution into a smart distribution. So sure, it is number one challenge. Number two challenge, as per our attendees, is skilled workforce, education, training, research, and development. For me, it is number one because you need skilled workforce first of all, and there is shortage nowadays for smart distribution. In all over the world, you have shortage because it's required some research and development work. Also, you have to be more innovative. The people should be more innovative, learning, and his style should be critical thinking, design thinking. All these the skills you have to be in one person that can think. You can make some brainstorming session, make some different analysis conditions for you, and can generate some ideas for your smart distribution. So sure, you need a skilled workforce, and it's a big challenge. And another one, education. You have to educate your all people working in your company in training, research. You have to be like a separate department like R&D for this smart distribution or smart grid, that continuously will be studying, because every time there will be some new change in the world, and we don't know in near future what will be the advancement in terms of technology and innovation. So these two I discussed. Now about distributed generation, this is another challenge I want to discuss. I will take maybe 5 more minutes for all of you, because the time is finished for 1 hour, but I can Miss Nawa, I can take 5 minutes.
Yes, sir, we can extend a little bit, no problem.
Okay, only 5 minutes, inshallah. So the distributed generation interconnection, I think another biggest challenge. If the home is smart and using the photovoltaic cell on the rooftop, have some wind power, have some bio, a small hydro like this. So the integration between these distributed generation with your centralized generation using a smart grid is a challenge, because this the load curve for all these distribution generation is not continuous. There can be too much surges. For example, there is a weather condition is very wrong, there is some snow falling, so your solar will not work. Wind condition is wrong, so your wind power will not work like this, and maybe in different timing it will give different output. So you need some solution like a storage solution, like a compressed power solution and some pumping solution. You will make some storage. So it means you have to make some electrical storage solution. Then you have to make some power quality study. Then you have to integrate between with your current load curve with this distributed load curve. So you need a lot of study to implement and integrate this distributed generation into your system using a smart grid. Another big challenge, on this customer awareness, I already write an article on my LinkedIn that this is another biggest challenge, because you know what happened? You are implementing all these strategies, but your customer is unaware. They don't know because you did not give them knowledge that what smart cities look like and how smart homes is more efficient. So customer awareness and customer engagement, or you can say stakeholder engagement, is I think the biggest challenge. And you have no, it is not a challenge. It is like you have to pay full attention. You can achieve very good response, like demand responses and your power management, if you have a good customer awareness or stakeholder engagement. Cyber security. Sure, if you have some smart system implementation, your cyber security or your risk, cyber attacks, like it will increase. So you have to pay a full attention on also this on cyber security. And all ADMS software have this another domains like cyber security. They have system like firewall and how to block the attackers, how to tackle with the fake reading, false reading. Maybe you are receiving this transformer is high loaded, but actually it is not high loaded. It is a fake report. So all these term, and sometimes your network can be broken by some hackers. So cyber security is another challenge. And creation of a smart ecosystem. This is the thing you have to build. And the scenario will be like this. You will be make some smart buildings, some smart homes, and you have a smart campus, like some buildings, some smart shopping malls are linked together, and there is a smart campus manager or some virtual manager that is managing this micro system. Then you have this smart campus differently in your city, and you have then a smart city. And this smart city is connected to your smart distribution and that connected to your smart grid. So if you will follow this ecosystem, I am sure 100% you will get the result from smart distribution. So this is all about smart distribution from my side in this limited time. Thank you for your valuable time with me. You can reach me out on this my email address for more discussion. I will be feel very happy if you will having more discussion with me randomly anytime. And on my this WhatsApp number you can write down. You can discuss with me this smart distribution, and if you need some knowledge, or also if you want to share your experience, I will be very happy if you will be communicate with me, and there will be some idea sharing. So it will be very good for me, also for you. So there is bi-directional information flow, and we will learn together. So thank you very much from my side. Now I will give back my control to IET team, Miss Novel. Thank you.
Thank you so much, sir. We have a few questions if you would like to answer them.
Yes, sure.
I'm going to start. Okay, first of all, people are asking about if you are going to share this presentation with them.
Yes, 100%. You can share all the people this presentation with them on email address. No problem. You can share.
All right. So you'll be receiving the presentation also. Don't worry about it. Sir has allowed us now. So we have a few questions. Some of them were answered, so I'm not going to go into details, but let's just get through. So somebody is asking, what is SEDI? So if you can describe it just a little bit.
SEDI is system average interruption duration index, SEDI. These are performance indices, like how you will check the performance of your system. So this for your duration. For example, if some fault happen, so how much time you will take to normalize to your normalize supply to your consumer. This called SEDI. So if you have normal distribution, you have you will receive call from some operators, or you have SCADA system, you will see this, okay, this feeder trip. Then you will call your operation people to please go to the field and maybe test cable, or maybe a manual procedure to look at the fault like this, and you make some operation, then you normalize the supply to customer by another source. It will take maybe 2 hours like this. So your SEDI is very high, worst. But for smart distribution, all these things will be done by your ADMS software, and it will practically speaking, in my case, when we are using this system, we take 5 minutes, sometimes 4 minutes. So you can see 2 hours and 4 minutes. So sure, your SETI will improve.
I hope that answers the question. So we have another question, that do we need the knowledge of telecommunication technology for the use of smart meters?
You know, for a smart grid, you should have some basic knowledge for your telecommunication, but it depends on your role. For example, if you are working on RTUs level or SCADA level, you are making configuration for your RTUs, you are making setting for real-time operation inside your RTU software. So sure, you have to be a knowledgeable person in communication, okay, telecommunication. But if you are a power engineer and you want to implement this smart distribution, you should have also some basic knowledge about how RTU is remote terminal unit work, what is SCADA, and how there are communication channels, what is router, how it is communicating. So it is not a big deal, but it's required for your better understanding. So that you should know what is going on from start to end in smart distribution and then smart grid.
Sure. So somebody has asked if smart meters, if there's any kind of tampering in the smart meters from the utility end, is that possible or does that happen?
Uh, okay, this is I think not possible. In a smart meter, it is not possible because you are receiving real-time data. You know, if you have power outage in your home, so you no need to call the company that I have no supply. Now company will automatically receive that you don't have supply. So it's mean they are continuously monitoring you. So you cannot tamper. First of all, there are many cyber and many electrical topologies here. But in electromechanical meters or some previous type of meters, people do like this. But for a smart meter, this is another advantage for distribution utilities, that this problem will be 100% will be taken. No problem.
So that's an advantage we would like to say. Somebody is asking to define two-way power flow in smart distribution. How does that happen?
Okay. As you know, in normal situation, what is condition in our houses? We have power coming from utility company and we are using. But in near future, there will be culture of distributed generation will emerge. Like maybe you can put some rooftop photovoltaic that will enough for your house, and maybe you want to sell back to the utility. So how you will sell, or how your excess power generation in your smart houses, all the smart city, if many people are generating the power, so how it can go back to your system. It will be sure there will be bi-directional power flow. Sometime you will receiving power from utility, and sometime you will supplying uh, power to the utility, so you can take also profit. So it's all about net metering. There will be some net metering. What is the input to your from your utility, what you give, and there will be some time you will receive some money from your utility company. This is called bi-directional power flow. And sure, for this bi-directional power flow, you will need and require reinforcement of your system, because on the consumer end, normally distribution is very weak on consumer end. If you are, maybe you are supplying the power to the system, so it will not be possible if some reinforcement actions or some system study is there. So by smart distribution, this two-way power flow will be beneficial for consumer and as well as utility company.
Okay, sir. So, Carl is asking, with growth of distributed generation, for example, some farmers are owning wind turbines. How is reverse power feed synchronized with centralized generation phase? Is it
Yes,
achieved locally or do you centralize smart control something?
this is all about this bidirectional power flow. You have net metering concept, and there will be some devices implemented in your farm, and you can sell out this power to your utility company. So this by smart distribution or a smart grid concept, it is possible, and it is happening right now.
Right. Okay, so we're going to take the last question, and it says, if you can please explain a little bit about demand response.
Okay, there are some type of load management. For example, if you have some generation or supply, and you have some demand from your system, and there is gap, so there is some shortage of power. Sure, you will require load management. Number one. Number two, there in the peak season or in some climate situation, there will be there will be surges in load curve and load responses from utility side. So utility cannot install centralized generation or more generation to tackle this situation. By using demand side management or demand response, this problem can be handled. For demand side management, what like load shedding, it is done by utility company. Load shedding, this is demand side management, and maybe they implement some forced action on consumer that you cannot use this load in this peak time or like this. But demand response is different. Demand response, you will give some incentive program to consumer, you will give some bonuses to consumer, you will make awareness to the consumer that if you will do these actions in your home, we will pay you some advantage. Another one, they will provide you some smart applications and smart things. So it is on your choice. For example, if you want to switch off these lights in your room and you don't want to use this thermostat, so you will be managing your load as per your desire. This is demand response. But if this load managed by utility company without any consent with you, this is called demand side management. So demand response nowadays is 100% effective regarding the smart grid implementation, and this is the fruit of smart distribution, that demand response is now applicable. So now companies giving incentive programs to the consumer that this, if you will use your electricity in this period of time, we will give you this much of amount, and can you decrease your thermostat on this time because now the temperature is very high, put please on not 27, put maybe 28, like this. So this is happening. So this is called demand response. This is the by choice of customer, by consent of customer, you are managing the load.
Okay, sir. So I guess this will be all for today. Thank you so much for your time. I would first like to thank all the attendees and the participants. Like they have been very interactive throughout the session. We had very nice polls, and I could see all of you asking questions and I would like you all to fill it. And on behalf of the attendees and IET, I would like to thank Mr. Tausif Ahmed for giving his valuable time and sharing his experience and knowledge with us. I hope everybody is very much thankful to you. Also, they can always contact you if they need anything. We are very thankful to you, and it's a goodbye from us, from IET Network, and from Sir. Thank you so much, everybody, for coming in. Thank you.
Okay,
Allah
thank
Hafiz.
you.